Hello everybody. Today I want to do a short illustrative video on my method, a method of reading comprehension for science textbooks. So the textbook we're going to choose is the second PU statistics textbook, which is found on Google. In the introduction to that textbook, we have the revision of formulae used in first PU. So here in the revision it says, for raw data the mean x and the standard deviation sigma are calculated by the formulae x is equal to sigma x by n and sigma is equal to square root of sigma x squared by n minus sigma x by n whole squared, where x is the observation and n is the number of observations. So what does this mean? So according to the method of reading comprehension for science textbook, we have to understand the meaning of the following terms. We have to understand the meaning of raw data. We have to understand the meaning of raw data. We have to understand the meaning of mean. And we have to understand the meaning of standard deviation before we apply this formula. So if we look up these terms on Google, we get the following. Raw data. Raw data is the data that has been collected directly from a primary source of data that is not processed by anyone. Okay? So raw data is the data that has been collected directly from a primary source. The primary source can be an experiment in a lab. It can be something done in real life like that. So raw data is the data collected directly from a primary source. The second definition is that of mean. Mean is the average or the most common value in a collection of numbers. Example, if we have the numbers 2, 4 and 6, the mean is 2 plus 4 plus 6 by 3. So 2 plus 4 plus 6 is 12 and the number of observations is 3. So 12 by 3 is equal to 4. 4 is the mean. That is the average value of these three numbers. Now, third definition is that of standard deviation. The standard deviation is a measure of the amount of variation of a random variable expected about its mean. So we have a mean. We have a mean like the number 4. Standard deviation is the amount of variation. It can either increase or it can decrease. So the two extreme values about which the mean value can change. That is the standard deviation. I'll read that definition again. The standard deviation is a measure of the amount of variation of a random variable expected about its mean. So it's the amount of variation expected about its mean. So let us take two examples. So let us take the above data 2, 4 and 6 and calculate the standard deviation and the mean. Mean is already been calculated, is 4. So standard deviation. Now n is the number of observations. N is 1, 2, 3. N is number of observations is 3. Now we draw tabular column. X 2, 4, 6 is the raw data. Sigma x is the sum of these three. So sigma x is equal to 12. X squared. 2 squared is 4. 4 squared is 16. 6 squared is 36. So sigma x squared. Sigma x squared is the sum of 14 plus 6 plus 36, that is equal to 56. Now sigma is given, the standard deviation is given by the formula sigma x squared by n minus sigma x by n whole squared square root. Right? So substituting the formula sigma x squared sigma x squared is 56, n is equal to 3. Sigma x is equal to 12, n is equal to 3. 56 by 3 minus 12 by 3 whole squared. So that gives a value of 1.63, right? 1.63. Now, what does that mean? Standard deviation is 1.63. Okay. Now, the mean is 4. 4 plus 1.63 is approximately equal to 5.6 is equal to 6. Right? So 6 is the highest value of the observed data. So, and then 4 minus 1.63 is equal to 2.37, that is approximately equal to 2, right? So 2 is the lower value of the data. So 1.63 is the standard deviation. The data varies between 6 and 2 by the value of 1.63, right? That is what it means. Now, let us take another set of raw data from Google. If we search for tabular columns for experiments in physics, we get the following. The deflection of a needle of a measuring instrument in a physics experiment is as follows. So these are the deflections of a needle of a measuring instrument for an experiment in physics. The deflections are 10, 6, 20 and 26. So here this is the raw data, 10, 6, 20 and 26. Now we have to calculate the mean and the standard deviation. The number of observations is 4. Let us calculate the mean and the standard deviation of the measurements. N is equal to 4. N is equal to 4, that is equal to number of observations. So we'll draw the tabular column. X is 10, 6, 20, 26. Sum of 10 plus 6 plus 20 plus 26 is equal to 62. Sigma x is equal to 62. Sigma x squared, square of 10 is 100, square of 6 is 36, square of 20 is 400, square of 26 is 676. Sigma x squared is equal to 1212. Now, this is the mean. Mean is equal to sigma x by n. Sigma x is 62 by 4, that is equal to 18. So this is the average value of the measurements. Now, standard deviation is equal given by the formula the square root of sigma x squared by n minus sigma x by n whole squared. So substituting the values, we get 1212, that is the value of sigma x squared divided by 4 minus 62 divided by 4 whole squared. So we get an approximate value of 7.9, which is approximately equal to 8. Okay. Now, according to the definition of standard deviation, sigma is the amount of variation of a random variable expected about its mean. So the mean is 18. 18 plus 8 is equal to 26. 18 minus 8 is equal to 10. So we have the extreme values of 26 and 10. So the standard deviation is 8. So we have applied the formula for mean and standard deviation, and the values fit the definitions given in the dictionary. Thank you.